Yo, 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 Algebrainiacs, man. Welcome to the Johnson-Gendro video hour.
But it's not an hour.
Yeah, but it's hour, not an hour. So we're happy with that. All right, 84.1, rational expression.
Can I just say I love this stuff?
You love this stuff? I do too.
Because it's factoring, and it's like a puzzle, and then you see it all fit together, and it's just so cool.
And it's, yeah, I agree. I love crossing stuff out.
Me too. I get a lot of joy out of that.
Who likes to make lists and cross stuff up? You're going to love it. Okay. So, rational. Look at the first 5 letters in that word, rational. Ratio. That
Fraction.
Like a fraction. Simplest form when its numerator and denominator are polynomials that have no common factors. This means we'll have to factor. Surely you jest. Okay. What's the rational expression in simplest form? State any restrictions on variables. So this is a little bit new. We don't do that. The biggest thing is, remember, you can't divide by 0. So in this problem, we have x squared and y squared. So neither x nor y can be 0. Otherwise, that would make the whole bottom 0, and the world would explode. And don't do that to your fellow man.
You know, that reminds me, we did, I think it was back in section 6.6, we did function operations, and we had to find out when the denominator was 0. That was the exception on the domain or something. So this is really similar to that.
All right.
Cool. Okay, so we got that part done. Restrictions are done.
Good. All right, now we have to see what we can cancel out. So 24 and 6 have a common factor of 6. So divide each by 6, we get 4 and 1, but you don't have
I'm
to
not
put
going to write the 1.
And you brought the negative up top, which is fine. It can go anywhere. Just don't write it twice.
Don't write it twice and don't lose it.
Right. Now, x2 and x3, they have a common x squared in common. So I can cancel 2 on the bottom and 2 on the top and leave just 1 on the top.
So we're subtracting those exponents?
Yeah, that's another way to think of it.
Yeah.
And then 2 and 3 for the y, I can cancel out 2 of them.
There's a leftover, but it is on the bottom.
Right, so we have 1 left on the bottom. And we're done.
Okay.
Could we do that y to the negative 1 on the top?
It is not considered, she's asking about this.
Instead of on the bottom?
In the math world, that is not considered fully simplified.
Oh, and we live in the math world, so we better abide by the rules. So all exponents positive.
I want to point out that you'll notice we don't even have any x's in the denominator, but that's still a restriction, and our final answer is still a restriction, even though it canceled. So that's important that you know before canceling, and we had the same thing when we were doing function stuff. So.
Yeah, it's not the original problem. Okay, number 2. Oh boy. We got pluses and minuses all over.
It's a quadratic.
It's like ax squared plus bx plus c.
And we know already that thing's going to have 2 zeros or 2 restrictions.
Right.
So this problem, and we're not ready to tell those yet, but...
So they're not just like 5 and 6?
I don't think it works like that.
Oh, it has to be factored
Okay.
into multiplication before you can tell the restrictions.
So I can't kill any kittens?
Oh my gosh. Shame upon you. No. Can't cancel unless it's multiplication. So, on the top, we've got 8 is 4 and 2. Looks like it'll do x plus 4, x minus 2.
Oh, we gotta think way back on our factoring, huh?
Yeah, yeah. And on the bottom, 6 is 3 and 2, but they're both negative. To make that negative 5 in the middle.
So we gotta multiply to get a positive, but add to get a negative.
Right.
Okay.
Now we can tell restrictions.
All right.
What would make that first parentheses 0?
So we're essentially, you don't have to do this, but you are solving that. You are finding the 0 of that.
We did that.
So that's 2.
So x can't be 2, otherwise that'd be 0.
And then also here,
X can't be
x can't be 3. All right, so we got the restrictions done.
Phew. All right, now I see a couple things to be canceled because they're the same. That and that can go away. Gone.
Oh, so this is your crossing off the list, huh?
Yes.
And we're not
Feels
killing
good.
kittens when we do that?
No, because it's multiplication.
Oh, okay. Got
You can do pieces when it's multiplication.
Got it.
Nice.
Okay.
All right, x plus 4 over x minus 3. There's nothing else that can be done. Those x's cannot go away because it's adding and subtracting.
Okay, so those are our two answers. Those are, we got the polynomial answer and the rational expression answer, I mean, and then the restrictions.
Sweet, let's do another one. Okay, this one is, top is not a quadratic, but they do have a GCF. I see a 4 they have in common.
I'm also worried about this order. What do you think about having X there? I would rather flip that around.
Yes, because later you're gonna see why. The negatives kind of mess things up.
I'm just
if you don't
literally
switch them.
rewriting that. I didn't do anything other than rearrange.
Okay,
Okay, now you said something about GCF.
so take out the negative 4. If you can take out a negative, do it.
Yep.
And then you're left with x minus 3.
Okay, because we took out a negative.
Right, so minus minus is plus 12. Now the bottom, that looks like a
Special case.
quadratic, and it's a fancy one. Difference of 2 squares,
Yep.
so x plus 3, x minus 3.
Oh, yes.
Now right here, if we hadn't taken that negative 4 out and hadn't switched them around, we would have had negative 3 plus x, and you might not have recognized that that still cancels.
Okay, so final answer for the rational expression is negative 4 over x plus 3.
Now we have to go back to the black expression there to get our restrictions. So it's before you cancel, so it can't be 3 or negative 3. Cool. Oh, you did that in a little abbreviated form.
Oh, yeah,
Very nice.
I bet we could do that too.
Uh-huh.
Ah,
Get even less. Mathematicians are lazy, so you want to do the least amount of writing.
Remember, she pointed out us rearranging the order allowed us to be able to recognize that GCF, and if we didn't recognize the GCF, we wouldn't be fully reduced.
Right.
Ooh, this one looks a little different.
Okay, so we have multiplication between the 3x squared and that. Okay, so we can cancel a little bit right now. I see a 3 and a 9 can be reduced.
Okay, I'm gonna make that a 3 on the bottom. That's like 1/3.
Okay, that x and the x squared cancel one of each, so it leaves an x on the top. Now, do I have to FOIL those out and get all that? No.
Because that's just one big thing to the third. That's no different than like x to the third or y.
Oh, so we got 2 on the top of that parentheses and 3 on the bottom, so there's an extra parentheses on the bottom.
Okay,
And
now
whatever's in there stays.
that's only possible because those are exactly the same in there, right?
Right.
Okay. I don't like how this looks, so I'm gonna move him to the middle.
Perfectionist. All right, now, but we have to go back to the original problem to do our restrictions, because we've already canceled. So go back to the beginning, we got x can't be 0.
Oh, okay, because we can't. That multiplied would be 0.
Right, 9 times 0 would be 0, so x can't be 0, and y can't be negative 2, otherwise that would be 0, and make the whole bottom 0.
And if you're having trouble seeing where she's getting at, what she's doing is she's finding the zeros of those terms. Here you divide by 9 and still get 0. Here if you set y plus 2 equal to 0 and solve, you get negative 2. Those are the things we cannot have.
Right, excellent. Okay, now, a little reminder about factoring, because it's been a while. This one, if you see a quadratic, but it doesn't have all 3 parts, you should always check GCF. You should do that anyway.
Yeah.
Especially on the ones that don't have maybe the part C or the part B.
Yeah, GCF or maybe difference of squares.
Yeah.
X is common in
So
both, so leaves us with 2x plus 5.
Okay.
Okay, these are just reminders for us to, we're not going to go through rational expressions that contain these, but just reminders. ABC.
I do have the A and the B and the C.
Oh, I remember this. In chapter 4, we learned that if there was a negative A, we didn't like it, so we removed it. And most students forgot this stuff that you're doing right now. She's rewriting with new signs, and that's really important because the new signs will be what we use to determine the signs in the final parentheses. We got to multiply to get a negative 64, which means 1 positive and 1 negative sign.
Alright, x and x, 64.
Plus and minus.
Yeah.
Oh, I know.
Do you know it?
16 and 4.
Alright.
And we need more positives left, so she's putting the plus with the 16 and the minus with the 4.
Yep.
So that's just a reminder how to deal with that negative, just like she mentioned in the last, I think it was problem number 3.
Okay, this
Ooh,
one.
no GCF.
Nope.
So, oh yeah, 4 spot, my favorite.
Ooh.
Fill it in. Fill multiply A times C. That's 36 factors, 36. 136. 2, oh, it's 2 and 18. 2 and 18, 2 and 18, 2 and 18.
Wait, so 2 and 18, so I need plus 2 and minus 18.
And don't forget your little x's. From there, look for a greatest common factor, x, and that leaves x plus 3x plus 2. Ooh, the next one, remember that third sign helps us figure out the new sign. Minus 6 is common. And that's going to leave us with 3x and change that to plus 2. Final answer, 3x plus 2, x minus 6.
Okay, all coming back.
And then one last thing to mention here. I don't remember how to do that. Okay.
Ooh.
How would you start that? This is just a reminder. We can't factor that. It's just an expression. So we got to rewrite that.
Oh, there we go.
Technical difficulties.
Negative x plus 3.
Oh, so we should factor out -1. Okay. So the reverse order means you should number 1 rearrange and probably going to have to factor out a negative if you had a minus.
Alright, that just makes things easier.
I think we're going to stop there. This is part 1 of 8-4, so we'll get some practice on simplifying before we go any further, and that'll be multiplying and dividing.
Groovy. See y'all.
Bye-bye. Bye.